so. And then lastly, we'll come back up to the Explorer tab here. And the Explorer tab is going to be a really useful tab for interacting with your smart contract. And that's because this is a tab that actually allows you to interact with your smart contract. So if you remember us looking at our publish contract page before we deployed our contract, we were able to see the write and read functions, basically the functionalities that we can use within the smart contract, but we couldn't really interact with them because we didn't have a smart contract for it to interact with. So in this Explorer tab, you can actually execute and call these functions right over here from your smart contract, or you can do these read functions. If you are familiar with using things like Etherscan, you normally can go on there and you can interact with smart contracts, but depending on your comfort level and everything, sometimes Etherscan can be quite intimidating to the average user. Instead, you can actually manage everything, again, all in one place with your smart contract. So Explorer gives you that ability to start interacting with your smart contract. So for example, here we can do in our read function, we can check the balance of. So we can check the balance of a wallet address. You can see here it asks for an address. So we just have to put a wallet address in here and it'll check the token balance to see how much tokens that wallet address owns. The great part is if you start putting in information, it'll actually check the data of your input here to make sure it's actually a valid wallet address. Again, you can, unlike Etherscan or something where you can put in anything that you want, this is actually going to check and make sure that you're inputting proper information. So what we can do is let's come to our extension here and open up our MetaMask wallet. And what we'll do is copy our wallet address. And if we paste our wallet address in here, you can see we don't get an error. And if we run that, you can see we get a much bigger number than 1 million. But when we minted the token, we only did 1 million. So why is there so much more than what we minted? Well, when it comes to interacting with numbers on smart contracts, you normally get two different types of numbers. You have a big number, which will go actually a little bit more in depth when we start using it within our application. But we'll also get sometimes larger numbers like this when we're dealing with token amounts, especially with ERC20s. And that is because this value in here is a value called Wei. So we can actually come to a Wei converter here. We're going to copy this value right over here. We're going to come over to a Ethereum unit converter. So Ethereum has different units in it, Wei being one of them. So you can see here there is 3 different units that we would normally refer to: Wei, Gwei, and Ether. So in here, like Ethers, if we're used to seeing the number 1, you can see here in Gwei, this number here, and then in Wei, it's even more. So again, our numbers that we normally get returned back, especially when we're dealing with things like ERC20 tokens, is going to be in Wei. So if we actually come in here and we paste in our Wei amount, if we look at our Ether amounts, that's the actual total that we're used to seeing. In this case, 1 million. So you can see here that is the return value, which is correct because we do own the 1 million tokens. So we can also go to write, which is actually going to be executing and writing data onto the blockchain. We have a few functions here, but we're actually going to test one out right now. We're going to go to transfer here, and we're going to transfer some of this cryptocurrency to another wallet. So we're going to come here, open up our MetaMask. We're going to select our other wallet here. We're not going to connect it. We're just going to select it. We're going to copy its address, come back to our account here, and we're going to paste that address in. Now, this amount that we want to send, again, when we're dealing with currencies and we're dealing with interacting with our smart contracts, we're using Wei values. So let's just say we want to send half of the tokens that we own to this wallet. So half of what we own is 500,000. So again, we can't send this value here because if we actually send that value there, in Wei, that is 0.00000000005 of the token, which we don't want. We want to send 500,000 tokens here. So we're going to come up to Wei and we're going to copy this right over here. And we're going to paste it into here. And what this is going to do is, again, call this function on our smart contract to transfer 500,000 tokens to this wallet address here. So we're going to now execute this, and we're going to get a transaction that pops up. You can see we are transferring, and you can see here it does a conversion for us, 500,000 TW tokens. So this here is the gas that we need to pay. We are sending 500,000 TW tokens plus this much Matic for gas. So we'll confirm that. And you can see our transaction went through. So let's actually take this address here. We'll check the balance of, paste that in, run that, and you can see we have the 500,000 in way. If we check our other address, we can check that and run it. And the same thing, we have 500,000 because both wallets will own 500,000. So again, the Explorer tab here is a great way to start interacting with your smart contract without the need of actually having an application that works with it. So if you just need to test out functionality, or you need to call certain functionality from your smart contract, you can do so in the Explorer tab. And again, you don't have to have an application that interacts with it. You can do that all within the Third Web dashboard and using Explorer. So we've looked at some of the options that our Third Web dashboard has to offer. But again, this was for our ERC20 token. We'll next go into our ERC721 token and look at some of the other options that differ a little, and we'll also then create our very own NFTs in it. So let's head on over to our ERC721 NFT. Now, there are a few more options here that you'll see that we didn't see in our ERC20 dashboard, mostly underneath the extensions tab. Under this top section, it's going to be the same for all contracts because it's showing the same relative information to those contracts. But for our ERC721, you can see here we have NFTs, claim conditions, we still have permissions, and we also have an embed down here as well. So if we come back to our contract checklist, you can see the next thing we need to do is upload our first NFT, and we have to head over to our NFTs tab. So we'll head on over to our NFTs tab here. And again, you're going to see some information, and you can see we have a claim button, single upload, and batch upload. Now, what we have to do is upload or lazy mint our NFTs to our smart contract, and that way they can then start to be claimed by anyone who claims the NFT from our contract here. Now we can do a single upload, and I'll do this as an example. So we'll just call this NFT01, and that will be the name of the NFT. You can name it whatever you want. You can get an image and upload your image here, but this can be an audio file, a video file, HTML file, PDF, 3D models, any type of file you can put right over here. You can add a description. So you can say this is an ERC721 NFT. You can add properties and traits. Now, these properties and traits could be something to describe or categorize NFTs. So if you have NFTs and maybe they have different background colors, you can categorize these background colors, and then in marketplaces, you can filter out through these properties. So you can filter out through background colors. If it's like red, you can just view all the red backgrounds. So properties are going to be a great way for you to categorize those NFTs out. And you can add more properties down here by just hitting add row. Now, once you filled out your NFT's metadata, you can lazy mint that NFT to your smart contract. Basically, it preps this NFT to be claimed or minted from your smart contract, but it won't be owned by anyone. So we can lazy mint an NFT here. We'll be prompted up with a transaction here. We can hit confirm. And what this again is going to do is lazy mint an NFT to our smart contract. You can see right over here, we have successfully minted our NFT. We have our token ID. Token IDs always start at 0, similar to like indexes in an array or something. It's always going to start at 0. You have your name, you have your media, your description. You can see here the owner is a wallet address, but it's all zeros or a null address. And if we click on the NFT here, you can see a little bit more details about it, the token ID, the standard that it is, the image a little bit bigger. We can also transfer or burn the NFT, but we can't do that because we're not the owners of the NFT. Only the owner of the NFT has the ability to transfer or burn. Transfer being the ability to send it to another wallet address. Burn, what this does is it sends the NFT to a burn wallet, or essentially destroys the NFT. But what it does is it sends it to a burner wallet, and no one has access to this burner wallet. So NFTs that go there, again, because things on a blockchain are immutable, anything that goes to this burner wallet, we consider destroyed because no one has access to do anything with it once it is sent there. So we'll come back here. Now you do also have the option to batch upload. And what batch upload is if you need to upload multiple NFTs, you can do them in a large batch. Now, the way that we did it is we uploaded single NFTs. And if you're making a collection of a few hundred NFTs or 1,000 NFTs, to single upload all those NFTs can take a very, very long time. So what you can do is batch upload, and you can download a CSV or JSON file. And we'll download the JSON file here really quick. And we'll open this up. And I have it open up in a code editor here. And this JSON file, what it is, it's an array of metadatas here. So you can see in one metadata, we have our name, which is the name of the NFT, the description. And this is going to be a reference to the image. In this case, it is an IPFS stored image. So we can put the IPFS hash here, and then we can put the attributes and everything, or the properties for our NFT. And essentially what you can do is you can, if I just close this here, you can create this array of all the metadata for your NFTs, and then you can just upload this JSON file, and it will then upload all those NFTs. So if we were to actually take this JSON file here and upload it here, you can see it'll bring in all of that information that we just did. And if we had thousands of NFTs, it would show up all 1,000 of them with the property and traits, the description, name, and everything like that. So if you wanted to, you could create a script or something that creates all the metadata for your NFTs if you choose to do so, or you can manually write them out if you want to do things like batch upload. So batch uploading is an option, especially if you have multiple hundreds or thousands of NFTs that you need to upload to your contract in order to claim. You can upload that. Again, you can download the CSV or JSON file as examples, and then use that as a reference to do that. Right here, though, we have our one NFT, but we can't claim this NFT, and that's because we need to set something called a claim condition. So anything that has a claimable, so if it's essentially a drop contract, you have something called a claim condition, which are conditions you can set in order to claim an NFT. So in order to allow our NFT to be claimed, under the NFTs tab, we have the claim conditions tab. And here's where we can set our claim conditions. Now, if we hit plus, there's a few different claim conditions, and we're going to go over them really quick. So there is the only owner. Only owner allows only the owner of the NFT or the smart contract to claim NFTs. This is ideal for someone who is maybe the project owner, and maybe they want to mint 10 NFTs to hold on the side for things like the team or a giveaway or something. You can do only owner. The great thing is you're not going to be charged for the NFT. So the NFTs are free to mint. You just have to pay the gas fee to mint them. And only the owner can claim this. So no other wallet can come in and claim an NFT. We have allow list, which means that we can provide a list of wallet addresses that can claim the NFT. Only if you use one of those wallet addresses can you claim it. So if your wallet address isn't in this list of wallet addresses, then you can't claim the NFT. I'm going to skip public with allow list and go over public really quick. So public means that this is open to anyone, and we can set things. So if I click on this, we can set things like how many NFTs will be in this drop, how much is it going to cost, and how many NFTs can be claimed per wallet. So this is going to be open up to anyone. So it doesn't matter what your wallet address is. If you try to claim an NFT, you just have to meet the criteria here. You have to be under the claim amount per wallet, and you just have to pay the cost of the NFT. Now going back to that public with allow list, it's a combination of public and allow list. And what I mean by that is it is open to the public. So if I click on this, it is open to the public. So you can set up the same things as you would a public claim condition. You can set up the number of NFTs within the drop, the cost, and you can select how many NFTs can be claimed per wallet. But you can also add a allow list override, which means you can add an allow list and you can change things like how much NFTs can be claimed by certain wallet addresses, how much a wallet address can pay for an NFT. So maybe certain wallet addresses you want to make that they can pay less for an NFT. You can set up those conditions here, just like you would an allow list, and drop in your allow list right here. So that is what a public with allow list is. Now for this example right here, we're going to do public, and what we're going to do is we're going to leave everything as is. We're going to make sure our NFTs don't cost anything. And again, if you want to, this is where you're going to make your changes according to how you want to set up your NFT. But for this tutorial and for this course, we're going to make it free right now so that we can claim our NFT. So I'm going to hit save phase. We're going to get a transaction that pops up. And we have successfully saved this claim phase. So with that being saved, we can now claim our NFTs. So coming back to the NFTs tab here, again, we have that claim button. Right now, you can see here that this NFT is not owned by anyone. We can come here and hit claim, and we're going to set the amount to 1. We're going to claim that NFT. And what this is going to allow us to do is now mint or claim this NFT. So again, we're not going to get charged anything because we made it free. We just have to pay this gas right over here. So we're going to confirm that. And once this transaction goes through, it's claiming and transferring the NFT to our wallet. So you'll see here that this wallet address is now changed from that null address of all zeros to our wallet address that we have connected to our dashboard. Now, many times when people want to launch these NFT projects, they want to make sure that it is viewable on top of marketplaces, something like OpenSea. So what we can do is come on over to OpenSea's marketplace here, which is one of the bigger NFT marketplaces. Now I am on testnets.opensea.io, and we'll drop this down in the description below. But this is the OpenSea marketplace for testnet contracts. Because OpenSea's main website only deals with mainnet contracts, you're not going to see any of your testnets if you deploy it there. So we're looking at OpenSea on testnet here. We can actually come back to our ERC721 NFT here, copy our address, and then we can come here in our search and then paste it. And you can see right here, our collection is actually automatically showing up in this NFT marketplace. And that's because NFT marketplaces are picking up on contracts that are deployed on the blockchain. So everything will appear here automatically as long as you have an NFT minted. And I'll go over that in just a moment here. So let's click on our collection here. You can see here we have our image, the name of it, when it was created. We have our creator earnings that we set to 3%. So again, it's respecting that royalty that we had set. We only have one item because we only have that one NFT that we just claimed. Now, what I mean by a collection only showing up when there is an NFT claim. What I mean by that is how marketplaces work is they're only going to show NFT collections once there is an actual token claimed on the NFT collection. So if we come over to our ERC1155 and we copy that wallet address and I search that wallet address, I'm not going to find that smart contract on the marketplace. And that's because we don't have a token that exists on that contract yet. So many times people get worried because they are testing out their NFT collection and they come over to the OpenSea's testnets and they don't see their collection popping up. That's because there hasn't been a token that was minted or claimed on the contract yet. So once you have a token minted or claimed, like we do this ERC721, you'll then see it appear here on the marketplace. Take our ERC1155, for example, you're not going to see that contract pop up because it doesn't have a token that exists yet. So what we're going to do next is we'll head over to our ERC1155. We're going to create our NFTs for this smart contract. So coming on the left-hand side here, under our extensions, we'll head over to NFTs. ERC1155s, again, are semi-fungible tokens. This means that we can create one NFT, but multiple people can own copies of that NFT. So a lot of times the way I like to explain it is you can think of it as a key or pass where you can have multiple passes or keys, or you can think of it as maybe like even a trading card where you can have multiple copies of a trading card and there are maybe like 30 or 3,000 of this card that exist. You can create one card NFT but allow 3,000 people to own it. Versus a ERC 721 where only one person can own each specific token. Each token is unique. So again, we have the ability to single upload or batch upload, just like we did with the ERC 721. I'm going to do a single upload here, and I'm just going to call this pass 1. We're going to get an image, which will be our pass image, and we can add a description. I can just say this is an ERC 1155 NFT. Again, we can add property or traits if we choose to do so. Maybe in this one, I'm going to add property and then I'm going to put pass and then we're just going to put digital, right? And then we're going to lazy mint this NFT. So again, our transaction will appear. We're going to confirm that. And again, we're lazy minting this to our smart contract. Then this is the ERC 1155 NFT. And once it gets lazy minted, we're going to have to set up our claim conditions. But it's going to be a little bit different than how we set up claim conditions for our ERC 721. So right over here, we have our pass that was just lazy minted. Now we don't have a claim condition option here on the left tabs. And that's because the way ERC 1155 tokens work is each NFT within this collection can have their own independent claim condition. And to better explain that, I'm going to create another pass here. I'm going to call this pass 2. And I have an image here that I'm going to use. So this is pass number 2. And then I'm just going to put this is another ERC 1155 NFT. This one, I'm going to put pass as key. So we can sort through that and we can take a look at that in the marketplace in a bit. So I'm going to lazy mint this second pass here. And I'm going to confirm that right here. All right, and we now have 2 NFTs within our ERC 1155 smart contract. Now again, with ERC 1155, each NFT within the smart contract is going to have its own independent claim condition. Unlike the ERC 721, where the claim condition is set on top of the entire smart contract, each one of these NFTs are going to have their own. So when you click into one, we're going to click into the first pass here. When we come to the detail page, you're going to have a claim conditions tab. And this is where you can set the claim conditions. So in here, just like we set claim conditions for our ERC 721, we can add a phase and we can add something like public. We'll just make this a free claim again, and we'll hit save phase. And this is creating a claim condition for this specific token ID. So we're going to hit confirm here. So this token ID here is going to be free to claim. And again, we are setting this claim condition only for this token ID. Once this goes through, we'll set the claim condition for the second token ID and we can take a look at the differences. So again, we have successfully set that claim condition. We'll head back. We'll go to pass number 2. And for pass number 2, we're going to also set a claim condition. You can see we don't have an existing claim condition here because each NFT has their own specific claim condition. We'll hit add phase. We'll hit add phase. We'll hit public here. This one we're going to actually charge. We'll put 0.001 Matic and we'll hit save phase. So for pass number 2, it's actually going to charge us a fee if we want to claim the NFT. Once that is saved, right up here in the top tabs, we can actually, let's take a quick look back at here. So again, we have our pass number 1, which is token ID 0. There is no supply. There is none claimed right now. Same goes for pass number 2. So if we come to pass number 2 really quick and we hit claim, we have our wallet address and we're only going to claim 1. If we hit claim, we're actually going to be prompted up that we're going to get charged. So up here, you can see we're getting charged 0.001 Matic to claim this NFT. And that's because the claim condition for this pass here, we made it that's the amount that you're going to get charged. So you get charged that amount plus gas. We're just going to reject that here. We'll head on over back to pass number 1. We'll hit claim. again, our wallet address. We're going to claim 1 and we'll hit claim. And you can see with this claim, we're not going to get charged anything because again, both those NFTs have separate claim conditions because they are part of an ERC 1155 contract. So I'm going to hit confirm here and actually claim this NFT. And there we go. We have successfully claimed the NFT. If we go back here, we're going to see our supply here is now 1. And now if I copy this address and I come to our testnet's OpenSea, remember, before we claimed that NFT, our collection didn't show up. Now, when you put in that collection into the search bar, you may not see it pop up, but we can search it here and you can see we have our third web ERC 1155 NFT, and now we have that one past NFT right over here. Now, properties and traits, the reason you put that in is we can take a look here at the filters on the left-hand side. This is where you can filter through those different properties and traits. So with that, we can now sort through and filter within marketplaces the NFTs within our collection. Now, the last thing we're going to take a look at here is something that you're going to see on both the ERC 721 and ERC 1155 smart contracts. So I'm going to come back to our ERC 721 here. And on the left-hand navigation here at the very bottom, if you remember, you're going to see something called embed. And if we click on embed here, what embed does is it gives us embedded code here that we can plug into anywhere, whether it's our website or if you're even using like a no-code website builder, you can copy this embed code and plug it into your website, and you'll have the ability to have a component that allows you to claim the NFT. Now, if we look up here, we do need something called a client ID. So we need to create a client ID really quick. We'll hit create. And you can see it created us an embed API key, which is going to be our client ID. So if we scroll down here, you can now see, you see this little preview here. This is what your embed code is going to look like. So we can actually copy this code right here to the right, and we can stick that into a website, or if you're using like, again, a no-code website builder, you can stick that into there as well. Configure a few things like gasless. So if we do gasless, we would have to use something like an Open Zeppelin relayer or economy relayer. And what this allows us to do is sponsor or pay for the gas on behalf of the person who is claiming. So instead of them having to pay the gas fee themselves, we can cover it on our end if we choose to do so. We're not going to get into setting up gasless relayers here, but if you are ever interested in setting up your own gasless relayer, we do have some videos that will link down in the description below that you can check out on how to set up. You can then customize things like the theming here. You can do dark or light theme, or you can have it match the user's system. You can select the color of like your buttons and everything. So we can do something like green. It'll make the button green and everything down here. And this is again a preview of what it would look like. Down here, you can toggle if you want to mint more or less, and depending on the max amount of mints that you allow, this will stop at the max amount. It says sold out right now because we minted our one and only one NFT that we had in our collection. But when someone connects their wallet, so they connect their MetaMask wallet to our embed here, they'll then have the ability to claim an NFT. So let's take a look at the ERC 1155 because then we'll be able to view this a little bit better. So coming to our ERC 1155 smart contract, it also has an embed feature as well. Now, the one thing that you're going to see at the very top here is a token ID section. And again, this is going to be for you to select the token ID that you want to display. So if we come over here to NFTs, because you have different NFTs that you can sell, you have to provide it with the token ID of the corresponding NFT. So right now in this one here, it is showing token ID 0, which is the first pass that we have here. If I change this to token ID 1, it's going to show the key once it loads. So you can see pass number 2. And again, you can select all those things like the theme, the color. So we can make this yellow or something if we wanted to. Now over here, you're going to see, we'll let this load really quick. Pass number 2, again, you can claim as much as you want, but you'll see that because we are charging 0.001 for this pass, it's actually going to show us the price that it's going to cost to mint the total amount that we have right over here. So you can see for 1, 0.01, for 2, 0.002. If we go back to token ID 0, it's going to say free to mint because, again, it is free to claim this NFT because we didn't add a price for it. So right over here, you can see mint is free, and it also shows that we already have one minted, whereas the other one, it shows 0 minted. So again, this embed, it gives you just an embedded code, which is, in this case, is just an iframe here that you can use, plug it in wherever you want, or embed it wherever you want. And again, if you're using like a no-code website builder, take this code, plug it in, and you will have created your very own website and NFT without writing a single line of code. So again, you have the tools here for Third Web. If you are looking to create something and you're not familiar with how to code, or you don't want to code anything, you have the tools here to deploy your own smart contract, set everything up, and then plug it into a website builder that doesn't require any code, and you'll have a full NFT project ready to launch. But then for those of you who want to take your blockchain development further and actually create front-end applications for your smart contracts, or even create your very own smart contracts, we have the tools to do that as well through Third Web. So in the next section, what we're going to be doing is taking a look at our Solidity SDK and how we can actually start creating our very own smart contracts using Third Web. We're going to go through some Solidity basics, and we're going to create just some really simple smart contracts to get an understanding of how they work. We'll then deploy those smart contracts and also show you how you can publish your very own smart contracts, like how we saw with the pre-built contracts that we just deployed. So again, that does it for this section here. We covered a lot of stuff with smart contracts. We went over the main standards of smart contracts with ERC20, ERC721, and ERC1155. We took a look at Third Web's Explore page and saw all the different pre-built contracts that we could deploy with a single click. We then also deployed your very own ERC20 cryptocurrency smart contract and your very own ERC721 and 1155 NFT contracts. We even took a look at our contract dashboard and took a look at all the different tools and how to set up these different contracts, along with the Explorer tab and how to actually interact with these smart contracts. We were able to claim our very own cryptocurrency and claim our own NFTs. And again, with all of this knowledge that you've learned so far, you can see how powerful of a tool Third Web is and how you can actually start creating these NFTs and cryptocurrencies without even writing a single line of code. But again, in the next section, we're going to take things a bit further and show you how to create your very own smart contracts and learn some Solidity basics and create some smart contracts of our own. So with all of that, catch you in the next section. Hey everyone, welcome to the next section. In this section, we're going to be covering a little bit more about creating our very own smart contracts and learning the basics of Solidity. In the last section, we covered and learned about the Explore page from Third Web and how it offers some pre-built contracts that you can deploy with a click of a button. We also deployed some of our very own smart contracts, including an ERC20, ERC721, and ERC1155. We also got familiar with our contract dashboard, learned what options it has to offer, and we also learned a bit more about Explorer, which allows us to interact and actually call functions on our smart contract. And an overview of what we're going to be learning in this section, we're first going to cover some of the basic tools and everything that you will need in order to continue throughout this course. From this point on, we will be coding a little bit, whether it's in Solidity or building out our front-end applications. And we're going to go through really quickly, again, some of those tools that are going to be required for you to do this. We'll then learn a little bit about Third Web's CLI, and we'll actually use our CLI to start creating our very own smart contracts. We're then going to learn the basics of Solidity, which is the programming language used to create smart contracts. And we're going to walk through and build a handful of our very own smart contracts. And with each project, we'll learn a little bit more about Solidity, understanding the fundamentals of it, and then finally deploying those smart contracts ourselves. We'll then also cover something called Publish, which is a cool feature that we offer at Third Web, which allows you to publish your contract, allowing others to deploy that contract with one click. Similar to how we have pre-built contracts in the Explore page, you can build your very own pre-built contracts and allow others to deploy it too. And again, we are going to be covering a lot in this section, so always check the timestamps down below in the description if you ever need to go back and rewatch something or take a break and come back. you can continue off at the spot that you left. And with all of that being said, let's jump on the computer and I'll show you some of the tools and everything that we're going to be using throughout the remainder of this course, and some of the things that you're going to need set up on your computer to continue. Alright, so on my computer here, and the first thing we're going to need it to do is download and install Node.js and npm. And if you don't have this already installed on your desktop, you can follow this documentation here. We're going to leave it down in the description below, but you will need this in order to continue with the remainder of the course. Some other optional things you can install are Yarn. We'll also drop down this in the description down below, and Git as well if you want to use that. Again, links will be down in the description. Also throughout this course, I'm going to be using a code editor called Visual Studio Code. Feel free to use any code editor or IDE that you want to use. If you want to follow along with exactly what I'm doing, you can download Visual Studio Code and your code editor will look exactly how mine looks when you go through this. I'll also be launching my code editor directly from the command line, and Visual Studio Code has a way of doing this. You can follow these instructions here, again linked down in the description, but it shows you how to configure everything so that you can actually open up your code editor and project directly from your command line after we create it. So again, those are some of the tools. The one required tool will be Node.js and npm, but the other ones are optional, and Visual Studio Code again is what we're going to be using in this course. So if you want to follow along exactly with what I'm doing, you can use Visual Studio Code. And once you have all of those things installed and you have your environment ready to go, we're going to take a look right now at ThirdWeb's CLI. Now, our CLI or command line interface here allows us to do a handful of things. If we look down here, we have some available commands like create, which creates a web3 app. We have install to add ThirdWeb's packages to your existing project. And we have another handful of things like deploy and publish as well, log in and log out, which we're actually going to go through right now. So what you can do is you can open up your command line. I'm on a Mac, so I'm going to open up terminal here. And once you have your command line open, we're actually going to take a look back at the docs here. But you can install ThirdWeb using npm yarn or pnpm here. We're going to use npm in case you didn't install yarn. But you can see this command right here. You can actually come here and copy it. We'll go back to our command line, paste that in, and what this is going to do is install ThirdWeb. And once that is done running, we can actually just type in ThirdWeb here into our command line. And this is going to bring up the ThirdWeb CLI here. You can see the version that we're on currently at the time of recording this video. We're on version 0.11.15. And we can see here that we have some options. We can check the version by using these commands here. We can have a skip update check. We can also do help as well. And we have those handful of commands that we saw previously in the documentation. Now what we're going to have to do is set up and authenticate our ThirdWeb CLI with our API key to allow us to do certain things that we're going to be doing throughout this course. So down here, you'll see a login option. And you can see here, this is to authenticate with the ThirdWeb CLI using our API secret key. Now, what is an API key and where do you get one for ThirdWeb? We're going to head over to thirdweb.com. We're going to connect our wallet. And once you're connected, you'll be brought up to your home screen here. And in these tabs here on the left, we're going to head over to settings. And in settings, you're going to see the option here for API keys. Now, if you followed along in the last section of this course, where we deployed our very own pre-built smart contracts, at one point we had to create an API key for the embed in order to copy the embed code and paste it into our site or wherever we wanted to use it. So you might have an embed API key here that was generated for you if you followed through that option. But what we're going to do here is create our very own API key that we can use to create our contracts and to create our applications. So up here in the top right, you're going to see create API key. We're going to click on that. We can now give a name for our API key so we can distinguish it from other API keys if we generate more. I'm just going to name this one TW course API, and we're going to hit next. Now, there are a few services that you can enable or disable. Now, we're not going to go in depth into each one here, but storage, just a quick overview, allows you to upload and download things to IPFS. We have RPCs here if you want to use ThirdWeb's RPC. And we also have smart wallets if you are looking to use our smart wallet service, and you can use our pre-built-in bundler and paymaster services. So again, you can toggle these on and off. For this course, we're just going to leave everything on for our API key. Just know later in the future, you can always toggle these and edit these even after creating the API key. So we're going to hit next here. The next thing we're going to do here is to set access restrictions. So over here, we have to put in the allowed domains for our API key. So this is any domain that we're going to allow to use this API key so others can't use it if they get their hands on our API key. So because everything that we're going to be doing here is just going to be run on our local device, I'm going to put localhost 3000 here. If you are deploying this to production, you'll put your own domain in here as well to allow that API key to work. Now we also do have bundle IDs over here. Now this is going to be for mobile apps, so iOS or Android, along with Unity games if you're using our Unity SDK. So if you're using one of those, you'll have to do the same thing, but you'll have to grab the bundle IDs of your application or game. But in this course, we're only dealing with web apps here, so we're going to just use these domains for our web apps. And again, I'm just putting in localhost 3000 because everything we do in this course will just be run locally on this device. I'm going to hit create. It's then going to generate you a client ID, which I'm going to copy and just paste on the side here for easy access. And this client ID, you can always just come back to your APIs in your settings and copy this client ID. This secret key, on the other hand, this is for authenticating your application on the back end. And this secret key, you can only view here once. So you're going to want to copy that secret key, store it somewhere safe on the side, because once we hit you have stored your secret key, you will not be able to retrieve that secret key again. You have to generate a new API key, and again, you'll have to change this wherever that API key was being used. So once you have stored it, you can hit I have stored my secret key securely, and there you go. We now have our new API key right over here. So again, you can always copy the client ID right over here. You can always come back into your API key and you can hit edit under general, and that will allow you to edit the name or allow list other domains or bundle IDs. Under services, you can toggle on and off those services that you want to allow for those API keys. And down here at the bottom, you can always revoke this key. So if you need to get rid of this API key, or maybe someone got access to it that you didn't want, you can always revoke the key here. You can come back here and you can always generate a new one as well. So again, that API key is going to be very important for using ThirdWeb's tools. And again, once you sign into your account on thirdweb.com, you can just head over to the settings tab to view your API keys. So coming back to our command line here, we're going to log into our command line. And in order to do that, we're just going to write ThirdWeb, and then we're going to do a login. Now, what it's going to ask you here is to please enter your API secret key, and it'll link you to the site that we were just on, but we have our secret key right over here. So I'm going to copy that. I'm going to come back to my command line. Now, when you paste the secret key, it will paste. You won't see it though. Just for secure reasons, it's not going to show you your secret key. But once you paste it, just hit enter. And like that, it will log you into the ThirdWeb CLI. So if we hit ThirdWeb login again, you'll see here that we are already logged in. So again, when you paste the secret key, you may not see it actually paste into the CLI. Just know that it does paste once you do paste it, and then you can just hit enter and it'll go through. If at any time you need to change your API key, or maybe you revoked your API key and the secret key is no longer valid, you can run a ThirdWeb logout. That will actually log you out of that secret key that you used to log in, and then you can just re-log in again with ThirdWeb and then paste in your new secret key and hit enter, and that will log you in with your new secret key. And now that we have logged into our CLI, we can now use it to create our very own smart contracts and even deploy them. So I'm just going to clear my command line here, and what I'm going to do here is run npx thirdweb create. And when we run ThirdWeb create, it's going to ask us what type of project do we want to create, and we can select an app, a contract, or a dynamic contract extension. In this course, we're going to be dealing with apps and contracts. And right now, we're going to be building our very own smart contracts. So I'm going to select contract and hit enter. We're then going to put in our project name. We're going to write these as my contracts. And you can select a framework. Now, we do support Hardhat and Forge. These are two popular frameworks for creating your very own smart contracts. In this course, we're going to be using Forge. So I'm going to select Forge here. And if you aren't familiar with Forge or Hardhat, you can follow along with me using Forge. If you're familiar with Hardhat, you can select Hardhat. A lot of the things that we will be doing are going to work on both frameworks. So I'm going to select Forge here. Now we're going to create our first smart contract. And this first smart contract, we're going to name Hello World. We'll hit enter again. Now, when creating a smart contract using ThirdWeb's CLI, you can select a few different options. You can select an empty contract, which will be creating a smart contract from complete scratch, which is what we're going to be doing here. But you have an option to select ERC 721, ERC 20, and ERC 1155. And what this will give you the option to do is build upon ThirdWeb's already pre-built contracts. So you can select a ERC 721, which will be the exact type of contract we deployed earlier in the last section. But if you want to add your own functionality, or if you want to customize the contract to your liking, you can actually get the code base for those contracts, change what you need to change, and then deploy your changed contract. So you do have the option to do that as well using ThirdWeb. But again, what we're going to be doing here is using an empty contract. So we're going to hit empty contract here. And once that is done, we're just going to change directory into our contracts. So my contracts. Let me just clear this to move this up there. And again, I'm going to be using Visual Studio Code, and we installed that little shortcut there that we can open up Visual Studio Code directly from the command line. So again, in the beginning of this section, I mentioned you could also install that as well. If not, you can just open up your code editor, open up your file, and you'll end up in the same place that we're going to head to next. And once opened up in your code editor here, I'm just going to close that welcome page. In your file directory here, if you're using Forge in your source folder, you'll see a file called contract.so. And if we click on that, you can see here, this is going to be where we can now start creating our very own smart contract. If you used Hardhat, you'll probably see a folder called contracts, and that is going to hold your Solidity file. So I'm just going to close this here. And what we're going to do is create our very first smart contract. And again, this smart contract is going to be called Hello World, which is just going to be a very simple smart contract that's going to go over some of the basics of Solidity. So we can take a look at the code that we are already provided with. At the very top here, you'll see something that's commented out that says SPDX license identifier, and it says unlicensed here. And basically this line or this comment indicates the license under which the smart contract code is released. Next line, you'll see something called Pragma Solidity. Now in my case here, I have a caret and it says 0.8.13. Now this may vary depending on when you created this smart contract. Because right here, this is the compiler version of Solidity that you're recommending to use on this smart contract. So again, Solidity is the programming language used to create smart contracts. And this caret here is just indicating that we are going to use any Solidity compiler of version 18.3 or newer. And then down here, you're going to see this contract. I'm going to get rid of this constructor really quick. We'll come back to that in just a moment. But you see contract here and contract. And this here is how we create our contracts. Now this contract here is similar to like a class in other programming languages. We're just declaring that it is a contract, and we're going to name this Hello World. So our contract is going to be named Hello World here. So in here, we can create all of our data and functions that we want to include inside of our contract or our little program that we're going to then deploy and put onto the blockchain. And now that we have the fundamental stuff of our contract set, let's actually start building our very first smart contract. So what I'm going to do here is create a variable, and we are going to put this here, string public message. Now this line of code here declares a variable. We're putting the type of the variable first, which in this case is going to be a string. Public is going to mean that anyone can access the information of this variable here. So anyone who views our smart contract will be able to see what value is stored under message. We can also make it private, which means that that value would only be readable by the contract itself. But in this case, we want to be able to show it to anyone who views it, so we're going to make it public. And then message here, or whatever you put here, will be the name of the variable. The next thing we're going to create is something called a constructor. Now, we saw this earlier before we deleted it. But a constructor is a special function that we can add into our smart contracts. And essentially what a constructor does is it's a function that is run one time only once the contract is deployed. So anything that we put within this constructor function gets called again one time on deployment. So what we're going to do here is we're going to make a message equal hello world. So up here, we declared a variable called message. The message variable is empty, it doesn't have anything in it. But on the constructor function, so once this contract is deployed, we're going to make message equal hello world. So once deployed, message should equal the string value of hello world. And then lastly down here, we're going to create a function. We can write function to declare that we are going to create a function. Name the function. I'll say get message. Because this is what this function is going to be doing. We're going to retrieve what the message is. So here we can now declare what this function is going to be. So just like we declared our variable up here public, we can declare that this function is public, meaning anyone can view it or execute it. We'll also make this a view function because this function isn't going to change any state of information on the blockchain. And all it's going to be doing is retrieving data that is already on the smart contract. We're going to do view here. And then what we're going to do is specify what is this actually going to return to us. So we're going to do returns. And in here, we're going to write the type of the return value. So in this case, string. And then we're going to follow that by something called memory. And what memory is just saying here is that the return string is temporary and will only exist in the instance of running this function. So in here, all we're going to do is return the value of message. So ideally, what this function should do is return to us hello world. And just like that, we have created your very first smart contract, which is a very simple hello world smart contract. Now, the next thing that we have to do is deploy this smart contract to the blockchain. ThirdWeb makes this very simple and easy to do, and you can do it directly from your command line. So I'm going to head back to my command line here, just clear this out, and we're going to still make sure that we're in my contracts here. And what we're going to run to deploy this is something called npx thirdweb deploy. Now, when we run this, we're going to be able to deploy our smart contract. And the great thing using ThirdWeb to deploy is you don't need to import your private key into your code or use your private key at any point in time. Normally, you would have to get your private key of your wallet, use that to deploy your smart contracts. But that also comes with a handful of security risk because you are exposing your private key. So with ThirdWeb, what we'll actually do, and we'll run through this as I run the deploy command here, is it will actually take the contract and upload its metadata to IPFS and allow you to deploy that contract on ThirdWeb's dashboard. And what that means is when you deploy to ThirdWeb's dashboard, you can then use any wallet that is connected or injected to your browser as the wallet that you want to use to deploy. So you don't have to expose any of your private keys in your code to deploy your contract. So again, we're in my contracts folder here, and we're going to do npx thirdweb deploy. What this is going to do is going to detect our project type. So it detects that it's a Foundry project, it compiles it, and then it uploads the contract metadata to IPFS. And what it will then do is open up a browser window. So it opened up this browser window right over here. Now, if you don't get this browser window that opens, or you need to reopen this browser window, in your command line, it gives you the link to that same browser window right over here. So if we head back to that browser window that popped up, you'll be brought to a page that may look a little similar to the pre-built contracts. And when we deployed our pre-built contracts, up at the top here, you'll see the name of your contract. In our case, it's called Hello World. And then we have the option here to select the network or chain we want to deploy our contract to. Now down here, you can select the drop-down and select your chain. Again, in this case, we are going to deploy it to the Mumbai testnet. So I'm going to hit deploy now. We'll get a pop-up here that has us confirm a transaction, which we are just paying the gas to actually deploy this contract to the blockchain. We'll then get a second pop-up like we did before. This is just a signature request to sign to add it to our dashboard. So we're going to hit sign here. And once it has successfully deployed, it'll bring us to a contract dashboard that is similar to the ones of like our pre-built contracts that we deployed in the last section. And once deployed, you should be brought to a dashboard similar to like the contract dashboards we saw with the pre-built contracts. You can see up here we have our name of our contract, which is Hello World, the chain that we deployed it on, which in this case is the Mumbai blockchain or the Mumbai testnet, and we have our contract address right over here. Now in the left-hand navigation here, we can head to the Explorer. And if you remember, Explorer is where we can start interacting with that smart contract. So under here, we only have read functions, and the only read function we have is get message. And you can see here the output is hello world, because when we run this get message, again, it's returning that message. And the message was set to hello world in our constructor function, which set that once the contract was deployed. So you can see right here, we have our hello world. And this is again, our first smart contract we have deployed, and we're viewing it and interacting with it right here on the Third Web dashboard. Now let's go back and build ourselves another smart contract, and this time we're going to build a smart contract that has a little bit more functionality to it so that we can start interacting with it a bit more. So we're going to head back to our code editor here, and in our file directory under the source folder here, we're going to rename this contract here. We're just going to rename this to Hello World. And we're going to create a new file within that source folder, and we're going to name this one coinflip.so. And what we're going to do for this smart contract is actually create a smart contract that emulates a coin flip. So we'll have a user select heads or tails. We'll then create a function that emulates flipping a coin, and then we'll return whether the user was correct or not within the smart contract. So to start off our smart contract here, we're going to, again, identify our license and put our pragma solidity, specifying that we can compile with version 0.8.13 or newer. We're then going to create our new contract here, and we're going to name this one CoinFlip. And within this, we are going to now, again, create our contract. So the first thing we're going to do in our contract is create something called an enum or enumeration. And an enum, we're going to use it is to define set named values. So we can set named values for something called coinside. And coinside in this case is going to have two values. It's going to have heads or tails. So we can set these values and we can name those values for the coin side. We're also going to need a second enum here. And this enum is going to be a flip result, and the result is either you were correct or you weren't correct, so win or lose. And we're going to reference these enums later on in our code when we have to share the result of the flip, and we're going to store that information onto the blockchain. We're then going to introduce something new, which is called an event, and you can think of events as a way to log information onto the blockchain. And what we're going to do with this event is log something called result. And then we can specify what is this result going to actually log onto the blockchain. And what we're going to do later on in the code is call this event or emit it whenever we want. In this case, when we flip the coin, we're going to call this event, and we will emit whether the user was correct or not in their guess. And within the results, we can put in the information we want to emit. So in this case, we want to emit the address. We can say indexed to the player. And this is going to be the address of the person who is guessing, so their wallet address that executed on that contract. And then we're going to also put in the coin side, which is going to be the chosen side We'll name it chosen side. And then we're also going to display the flip result, which is going to just be a result. So what this is going to log onto our blockchain is the address of the player, the side that they chose, and then if they were correct or not in their choice. So what we'll do here is create a function to flip this coin. So we'll call this function flip coin. And now what we'll have to do in this flip coin is we are going to take an argument, and the person who is calling this function has to say either heads or tails. So we're going to say coin side, and we're going to name this chosen side. So whatever side they choose. We're going to make this function public because anyone will be able to call it. And within this function, we now need to create a function that is going to randomly select heads or tails. And then if the person calling the function is correct, we'll then emit right here in our event that they were correct. And if they are wrong, we're going to emit that they were wrong. Now we need to generate a random number here. And we can do this by using this piece of code here. uint256 is the type of our variable of random number, is what we use for our numbers here. And you can see here that we have a piece of code here. Essentially what this is going to be doing is generating a combination of the current block timestamps and the address of the person who is calling the function. And then the result is going to be converted to an integer, and we're going to use modal2 to either give us a result of 0 if it's an even number, or 1 if it was an odd number. And we're going to use that 0 or 1 to identify if the coin flip was heads or tails. So what we'll do here is we're going to get a coin side, and this is going to be our result here. And this is going to equal coin side random number. So again, we're going to get our result, and it's going to be a 0 or 1. And 0 is corresponding to our heads here. Tails is corresponding to 1. And depending on what our random number was, we're going to get a result. We'll then set our flip result to flip result. And this is, we're going to check if our chosen side equals result. And if it does equal result, then your flip result will be win. And if not, your flip result will be lose. We're then going to emit our result to the blockchain using our result event here. And we're going to provide it the msg.sender. So msg.sender, this is going to be the wallet address of whoever is calling this function. The chosen side, so whatever chosen side they chose over here when they executed the flip coin function. And then we're going to emit the flip result. So depending if they were correct or not, this will be win or lose. So again, this is our coin flip contract. Just to quickly go over it, we have our enums up here, which is allowing us to set name set values to coin side and flip result. So coin side has the options of heads or tails. Flip result, you can either win or lose. We have our event here called results. And anytime this event is emitted, it's going to display the address of the player who called the function, the side of the coin that they chose, either heads or tails, and then the flip result here, so whether they were correct or not. And then we'll come back to our command line here. And then what we'll do again is run npx third web deploy. We'll hit enter. Now, what's going to happen here is our CLI is going to detect all of the contracts that we have. Now, you're going to see coin flip and you're going to see hello world. You may see it 2 times because we changed the name of the file here, but using your up and down arrow and the space bar, you can select the contract you want to deploy. In this case, we're going to deploy the coin flip, and then we're going to hit enter. And just like us deploying the hello world contract, we're now going to deploy our coin flip contract. So we can take this URL right over here. We'll copy that, head back to our browser, paste that in, and then we'll be brought to our deploy page here. Again, we are deploying the coin flip contract, and I'm going to deploy it to the Mumbai testnet and hit deploy now. I'll confirm that transaction to pay the gas to deploy the contract. We'll then sign the signature here to add it to our dashboard. And you can see here it has been successfully deployed, and we're now brought over to our coin flip dashboard. So just like we did on Hello World, let's head on over to the Explorer here. And then in our Explore page, you can see here, we only have a write function. In this case, it is our function called flip coin. And it is going to ask us for a chosen side. So in here, we're going to provide it with a 0 or 1, 0 being heads, 1 being tails. So we can just put 0 here. We're going to execute, which is going to run this function. Now, because this is a function that is going to write some type of data to the blockchain, anytime we execute this flip coin function, we're going to have to pay gas to execute it. Unlike our read function that we had in our Hello World contract, which was just to view information that was already there on the smart contract, we are creating new information and writing new information to the blockchain with the flip coin function. So anytime, again, we call this, gas has to be paid. So we're going to confirm that here. And once that function executes, we'll give it a moment. You can see we get our result back here, and we get an output here at the bottom, which may be a little confusing and intimidating. Basically has the information of the contract this function was sent to, where it came from, the transaction hash, so we can look it up on a block explorer, the block number, and a bunch of information there. But if you remember, we created an event on this contract to emit anytime this function was called. So on our left-hand side, we can go to the Events tab here. And you can see here that we have a result event, which was the name of the event that we created in our smart contract. And if we drop that down, you can see here that we have player, which is the wallet address of the wallet that we just used. We have chosen side, which was 0, which was heads. And then we have result here, which is a 1, which means we didn't get it correct and we lost. So let's try run this Explorer again. Let's do another 0 here, and let's see if we can get a winning flip. So it took me a couple times, but on the third try, you can see here that we chose 0 or heads again, and then our result was 0, which is the win result. So you can see here, all those events were emitted onto the blockchain, and the blockchain now has a log of all the results of every coin flip that was executed on this contract. We have the transaction hash here if you wanted to look up more information on that on a block explorer, but we can see here that we have our events of result. And again, we have our result that shows, which is the player address, the side was chosen, and then the result of the flip. So again, that was our second contract, and we learned a little bit more about enums, events, and actually creating functions that are going to execute and write information to the blockchain. The next sample contract that we're going to build is something like a tip jar, which is actually going to allow us to actually start sending digital funds or cryptocurrency between a user and the smart contract itself. So in our code editor here, let's create another smart contract and build this out. So we're going to open up our files here in source. We're going to create a new file, and we're just going to call this one tipjar.so. And we'll start off again by having our license identifier, our pragma solidity. Then we're going to create our contract here, and we're going to call this one tipjar. And in our tip jar, again, we're going to create a smart contract that allows people to leave a tip, add it to our tip jar, and only the owner of the tip jar will be able to withdraw the funds that are in the tip jar. So to do this, we're first going to create a variable called owner. Now this variable is going to be a wallet address. It is going to be a public variable here, and we're going to name it owner. And what we're going to do is set the wallet address of whoever deploys this contract to the owner variable. And what we're going to be able to do with that is then restrict some of the functions like the withdraw function to only allow the wallet address of the owner to be able to call that function. Now we're going to create a couple events here. The first event is going to be a tip received, and this event is going to put the address of the tipper, and then we're going to use a uint 256 to put in the amount that that person has tipped. We'll get rid of this S here. So event here, this event is called tip received. Again, it will emit the information of the address of the tipper, and it will add the number of how much that person has tipped. We'll then create another event called tipped withdrawn, and the address is going to be the owner, and the amount withdrawn is going to be a uint 256. So this event here will be emitted every time someone leaves a tip. We'll know what wallet address was the tipper and how much they tipped. And this second event here will emit the information. It will always be the owner address here. And then we can see the total amount that was withdrawn from the tip jar. Next, we're going to create our constructor here. And again, this constructor function is a function that only runs once this contract is deployed. And what we're going to do in this constructor function is set our owner variable, which was the variable that we created up here, to the msg.sender. And again, msg.sender is the person who is executing the transaction. So in this case, whoever is deploying this contract becomes the owner, or their wallet address gets set to the owner variable of our contract here. And that's all we're going to do in our constructor, is we're just going to set the wallet address of the deployer to the owner variable. But the next thing we're going to do is something called a modifier. And what the modifier does, in this case, we're going to name our modifier to only owner. And modifiers are used to change the behavior of functions that we create within our Solidity file. In this case, we're going to make sure that this modifier checks that the wallet address who is calling the function is the owner wallet address. And we can add this modifier to certain functions that we want only the owner to be able to call. So in this modifier function in here called only owner, we're going to require that the person calling the function is their wallet address is equal to the owner wallet address. And if it is not, we can say only the owner can call this function. And we're going to implement this only owner modifier in our withdraw function because only the owner should be able to withdraw the funds within our tip jar. Now we're going to create our first function, which is going to be called tip. And this function is going to be for people to tip or add a tip into our tip jar. So this function is going to be public because anyone will be able to call this function here, but we're going to add something new, which is something called payable, because what we're going to actually be able to do with this function is send a certain value over into the tip jar. And payable is what we use when we're actually going to be sending cryptocurrency using our smart contract. So what we're going to do in this payable here is we're going to use something called require, which we actually did in our modifier up here. And we need to add a condition here, which is what are we requiring? And then we add a message, which will be like an error message if the requirement isn't met. So the requirement here is that the msg.value, or the value that the person is sending over using this contract, is greater than 0. Because we don't want someone to just call this function and not actually tip something, because then they'll be paying gas on this function for nothing. And then for our error message here, we're just going to say you must send a tip to use this function. And then what we'll do after that is we'll emit our tip received event, and the address is going to be the person executing the tip because they are the tipper. And then msg.value is going to be the value that they choose to tip. And that again is going to be the amount that is tipped there. This is the tip function. It's a public function. We made it payable because you're going to be actually sending cryptocurrency along with calling this function here. We require that the value that the person is sending is greater than 0. If not, they're not going to be able to call the function. And when they do send a value, it's going to emit the tip received event, and it is going to record on the blockchain the address of the person who left the tip along with the value of the tip that was left. Now, one thing to note with this tip here, the value or the cryptocurrency is going to be sent to the smart contract. So smart contracts can actually hold cryptocurrency for you. And what we're going to create next is a withdraw function. So what we'll be able to do is withdraw or send over the cryptocurrency from the smart contract to a wallet. And in this case, it's going to be the owner's wallet. And the only person that should be able to call this withdraw function is the owner. So again, we're going to create a function here called withdraw. We'll call it withdraw tips. It will be a public function, so anyone will be able to view the function, but only owner, we'll add that in there, which is our modifier. Only owner will be able to call this function. So we can add our modifiers to our functions like this. And what it's going to do is call our modifier function here, and it's going to check that the executor of the function is equal to the owner address of the smart contract. And if it isn't, it'll say only the owner can call this function. And what we're going to do in withdraw tips is we're first going to make sure that there is a balance in our smart contract to withdraw. We don't want to, again, execute a withdraw function on a balance of 0, and we're going to end up using gas to receive nothing or withdraw nothing from our smart contract. So let's actually get the balance of the cryptocurrency stored in the smart contract first, and then see if it is greater than 0. So we're going to get a uint256. We'll call this contract balance, and this is going to equal the balance of the contract. Now we can do this by executing address this.balance. And what this is doing is getting the address of the smart contract and then getting the balance of that smart contract. Next, we can require that the contract balance is greater than 0. And if it's not greater than 0, we can just say there is no tip to be withdrawn. And if it is greater than 0, we're then going to pay out and transfer that balance to the owner's wallet address. So to do this, we're going to create a payable to the owner. And what we're going to do here is transfer the contract balance. We'll then emit the tip withdrawn event that we created up here, where the address is going to be the owner, and then the amount that was withdrawn will be the contract balance. So again, this is a way where we can withdraw so again, this function is to withdraw tips. It is a public function, but can only be called by the owner. It checks the contract balance. We then require that the contract balance is greater than 0 in order to continue the function. If it is greater than 0, we make a transfer to the owner of the contract, and we transfer the contract balance, and then we emit the event of how much was withdrawn. Now we're going to add one more function in here, which is going to be a read function, which just reads the balance of the contract. So maybe we want to check how much is actually within our tip jar. We can create a function here. We'll call it getBalance. This function will be a public function. It'll be a view function, just like how we did in Hello World. And we have to specify what it's going to return here. And it's going to return to us a uint256, which is the balance of the contract. So in here, we're going to return, and we're going to do the same thing that we did to get the contract balance up here in our withdraw tips. We're going to get the address of the contract, of this contract, and get the balance of it. And that's the value we're going to return when we call the getBalance function. So that does it for our tip jar smart contract. Now we'll quickly go over it again. Up here, we set a variable called owner, which is going to be a wallet address. We have a couple events that we can emit. One of tip received, which will record the tipper and the amount they tipped, along with tip withdrawn, which will have the owner address and the amount that was withdrawn. In our constructor, we set the owner variable to the wallet address of whoever deployed the tip jar contract. We then have a modifier called onlyOwner that we'll add to our functions and require that the executor of the function is equal to the owner's wallet. We have a function that is public and payable because we are sending cryptocurrency with this function. And this is our tip function. And we just require that the tip being sent is greater than 0. And then we will emit our tip received event. We have a function called withdraw tips, which is public, but can only be executed by our owner using our modifier. It checks the contract balance, makes sure that it is greater than 0. If it is, it'll then transfer that balance to the owner's wallet. And then finally emit the event that the tip was withdrawn along with the amount that was withdrawn. And then we finally have our get balance function, which is just a read function, which we can view, and it returns us a uint 256. So in this function, it is going to return to us the balance on this contract address. So with that, we are going to head back to our command line here. We are going to run npx thirdweb deploy once again. It is going to find all of our contracts. We're going to go down to the tip jar contract, hit space, and then hit the enter key to deploy that tip jar contract. We'll then take that URL, head back to our browser, open that up, and you can see here we have our tip jar contract, and we're going to deploy it to the Mumbai testnet. We'll confirm that transaction to pay for the gas to deploy our contract, and we'll sign the signature to add it to our dashboard. And there you go, we have now successfully deployed our tip jar contract. So let's start interacting with this a little bit. We'll head to our Explorer tab again. You'll see this contract has both write and read functions. If we read function and we use our get balance function here, you can see it gives us 0 because we don't have anything in our tip jar yet. If we look at the owner read function here, it has a wallet address, which is the wallet address of the wallet we use to deploy the contract. And in our write here, we have our two functions of either leaving a tip or we can withdraw tips. So leaving a tip here, you can see we have a input field here for the value of the cryptocurrency that we want to send for our tip. Now, the great thing with thirdweb and our Explorer dashboard is anytime we need to send a value with a function, we can actually use this using a native coin value. If you remember in the previous section, we went over the different units that you have to use when interacting with smart contracts. And normally smart contracts, you have to use the way unit. And you'll have to convert the number that you would normally see into way if you wanted to provide the right information to the smart contract. But you can see here, we can use the native currency value in ethers to send with this transaction. So for this example here, we can actually put 0.001, and this will send 0.001 and automatically convert it to us when we execute this function. So let's put 0.01 of our native coin. Right now in our wallet, we have 0.239 Matic. So if we send 0.01, we can execute this here. We're gonna pay the gas, and you can see here that we are sending over 0.01 Matic. We'll hit confirm. And you can see again, we get an output with that information of our transaction. But if we head over to our read function now and we hit get balance, we're gonna have a actual balance now within our smart contract. Now I can copy this number here. We'll head to that ETH converter that we used earlier. We'll paste that into way, and you can see that value is that 0.01 value. Now we also have an event that was emitted because we left a tip. So a tip was received. And you can see here the tipper was our wallet address, and then the amount, that amount again is going to be in way. So we can come back to the Explorer here. We can actually now go to withdraw tips, and we can execute our withdrawal. You can see here that we went down to 0.229 Matic. So we can execute the withdraw tips here, pay the gas to execute the transaction. And this is, again, checking the balance of our contract and withdrawing the whole balance of our contract out. So now if we head back to read and we get balance, balance is back to 0. And if we head over to our events here, you can see we have tip withdrawn, and we can see that the owner, which is our wallet address, and the amount that was withdrawn was that 0.01. So that was our tip jar contract. And again, we learned a little bit more about Solidity through this contract. The next contract we're going to build is a message board like contract, where people will be able to send messages to our contract, and we'll be able to store and display all of the messages that were sent. All right, and back in the code editor here, we're going to create our next contract project. So back in our source folder here, I'm going to create a new file and call this one messageboard.so. And again, we're going to create a simple contract that allows people to create a message and store it on our contract. And then we'll be able to retrieve those messages from our contract. So again, we'll be using the things that we learned from those previous contracts and applying it to this message board contract here. We'll start with our license identifier and our pragma solidity. We'll then create our contract and we'll call this message board. Now in this message board contract, we're going to create a variable again with an address and we'll make it public for the owner. We'll then create another variable to hold our messages. Now we'll create a string array here. That way this is an array that is going to hold all of our messages, which are going to be strings. We'll make this public and we'll name it messages. We'll create an event here called new message. And this event will record our address and they will be called the sender. And then we'll have a string, which will be the message that that person has posted on our message board. We'll create our constructor function here. And all we're going to do is set the owner to the deployer of the contract. We'll create a new function here and we'll call this post message. And post message is going to take a string and we'll use memory here because we're only going to use it in this instance. And we're going to name it message. This is going to be a public function. So what we're going to do here is we're going to add the message that this person posts to our array of messages here. So we're going to get our array of messages. So we're going to get messages here. And we're going to push the message that the person puts in here into this function into our array of messages. We're then going to emit a new message and the address or the sender is going to be the person who called this function along with the message, which is going to be the message that they called the function with. We're going to create a function that gets the message count. So get messages count. And this isn't going to take any arguments, but it is going to be a public function. It is going to be a view function because we're just reading information that is already on our smart contract. And this is going to return a uint256, which is going to be a number, and it's going to return the length of our message array. So depending on how much messages we have in our array, this is going to return the amount of messages that we have. And then finally here, we're going to create a function called getMessage. And what this is going to take is a number, so uint256. And this is, we're going to name it it's going to be the index of the message that we're trying to get from our array. So again, this is going to be a public function here. It is going to be a read function or a view function because we're just, again, reading information that is already there on our smart contract. It is going to return here a string, and then we make sure to add memory after that. And we're going to require one thing. The first thing we're going to require is that the index that we are asking for is less than the messages dot length, because we want to make sure that the message that it is retrieving actually exists. And the only way it exists is if the number that we asked for is actually less than the length of the array that we have. And then at the end, we're just going to return the message in the index from the messages array that the caller specifies up here in the argument. So that is our message board contract. Again, we're using some of the things that we learned in previous contracts. We're stating some variables up here. We have our address, which is going to be our owner variable. We have an array of strings here that we're going to store our messages. We have an event here that is going to get called and emit a new message event. We have our constructor function, which is going to set the owner of the contract to the deployer. We then have a function that posts a message. So it takes a message and pushes it to our message array, then emits the new message event. We have a function that gets the message count. So it checks the length of the message array and returns us that value. And then we have a function called getMessage, which takes a number which looks up the index of the message within our messages array. So let's go back to our command line here. Let's just clear this out. And let's run npx third web deploy once again. This time we will look for our message board, hit space, and then hit enter to deploy that. We'll then copy our URL here, head back to our browser, open up a new tab and head over to that URL. And you can see here, once our information pulls up, we have our message board contract, and we're going to deploy that to the Mumbai network. We'll hit deploy now, confirm that transaction to pay the gas to deploy our contract. And then we're going to sign that signature to add it to our dashboard. And once that has been deployed, we have our message board contract dashboard. We can head over to the Explorer tab again. You can see we have our post message write function here, which will take a string and we can post our message. We also have our read functions here, so we can get a message based on the index in our array. We can get the message count, which right now is 0. And then we have messages here, which is just like get message. It's reading the messages array variable directly from our contract. And then we have the owner, which is the wallet address we use to deploy the contract. So let's post a message here. And we'll say, hello, testing first message. And we can execute this transaction here. We gotta pay gas because again, we are writing some information to the blockchain and to our smart contract. We can see our output here with the information for our transaction. If we head to read, we can go to get message count. We are now at 1. If we hit get message, we can put in index 0 because this is our first message. We'll hit run. And you can see here we returned our hello testing first message, which was the message that we just posted. So that is, again, our message board. So we can keep adding messages here. I can just put this is another message. We can execute this. It'll add another message into our array of strings, which is acting like our message board. Again, we can check our message count. We're now at 2, and we can get message of index 1 this time. And we have our other message. We can check again index 0, and that will be our first message right over here. That was our example of a message board, just practicing some of the things that we've learned in our previous contracts that we deployed. Now, our last contract that we're going to deploy here is something called a profile status, and we're going to learn a few different things building this contract out. So what we're going to do is head back to our file directory under source, add a new file. We're going to call this one profile status.so. And then in here, we will create our contract, and we're going to call this profile status. And in our profile status, we're going to create something called a structure. So we're going to call it a struct here. And this struct is going to be called status. So the structure of our status, so our status is going to hold two different things. The first thing is going to be a string, which is our status message. And then it's going to hold a bool, which is like a true or false if the status actually exists. So whenever we reference to this status struct here, we can check two things. We can either check the status message, or we can check if the status exists. And the reason we're doing this, we're checking to see if a address already has a status that exists. And if they do have a status that exists, we're going to check the message of the status. So this is a way of structuring data types that you want to create within your smart contract. That way you can access them and reference them easily. What we can do with this status is now link the status struct to a address. And we can do that by using something called a mapping. And what a mapping does is it takes something, in this case, it's going to take an address. And what it's going to give us back is a status. And by status, it means it's going to give us back this status structure that we created right over here. And we're going to make this public, meaning anyone can view it. And we're going to call this user status. So when we provide this mapping a wallet address, it's going to check the status struct of that wallet address, and it's going to return us this information of status message and the bool if it exists or not. Next, we're going to create a couple events. So the first event is status created, and what this is going to do is take the address, and we're going to call this wallet here, and we are going to then put a string, which is going to be the status. So when a new status is created, meaning someone updates their status for the first time, it's going to include their wallet address and then the status that they created. The other event that we're going to create is called status updated. And this is going to take the same thing, except we'll name this one new status. So this is what if someone already had an existing status, but they updated it to a new status. So now we're going to create a few functions. The first function we need to create is when someone creates a status for the first time. And what we're going to take in the argument of this is a string. We're going to make sure we use memory. And this is going to be our initial status. This function is going to be public. Again, anyone can call this function. We're going to require that the user status, and then we're going to use brackets here, msg.sender.exist, and then we're going to say status already exists if it does. So what we're doing here is we're checking the mapping of the user status, and we're providing it with the address of the person who is executing the function. And what it's going to do is map that address to the status struct. And then what we get in return when we provided the wallet address is this status struct, and we're checking the exist, which is this bool here. And if this bool is true, again, we're saying not in the beginning here. It means if it already exists, we're going to say status already exists. Therefore, this isn't going to be an initial status update. But if this is false here, then we can create an initial status update. So what we're going to do is on our user status, so our mapping, we're going to, again, it's the mapping of the msg.sender. And this is going to equal a new status struct here. And we're going to provide it the status message, which is going to be our initial status message that we provide here in our argument. And we're going to change exist to true. We'll then emit status has been created, and we'll give it our msg.sender and the initial status. So again, this create status is for the initial and the first status that someone creates. The next function we're going to create is for if someone wants to update their status. This means that they already have a status that is posted on our contract and they just want to change it to something new. So in here, we're going to have an argument for a string, which we're going to call new status. This is going to be a public function here. And what we're going to do in this function is require, let me just spell that correctly. We're going to require that the mapping of the user status of the address that is calling this function exist. If it doesn't, we're going to say status does not exist, and they're going to have to create a status first. Then what we're going to do here is map through and get the mapping of the sender, and we're going to update the status message to the new status that was provided. We'll then emit the event that their status was updated and provide the sender address along with their new status. We'll then create a function called getStatus, which takes a wallet address. It's a public function that anyone can call. It is going to be just a view function or a read function because, again, this information already exists. We just want to be able to obtain it, and it's going to return us a string or the status of the wallet that we put in. Now we're going to require that the wallet address that someone looks for already exists, and if it doesn't, we return status does not exist. And then if it does, we're going to return the status message of that wallet. And this does it for our profile status. So what we'll do here is come back to our command line. We will run npx third web deploy once again. We'll look for our profile status, hit space, and then enter to deploy. We'll copy our URL here, paste it in our browser. And now we have our profile status contract, and we can deploy that to the Mumbai testnet. We'll then sign the transaction to add it to our dashboard. And once it has been successfully deployed, we'll head over to the Explorer tab once again. And we're going to go to get status. We're going to copy our wallet address. So if I come up to my wallet here, we can actually just copy our wallet address right here. And I'm going to paste it in here, and then I'm going to run it. And you can see we get an error saying that status does not exist because we didn't create a status yet for this wallet. So we know that our error works and that it won't return us a status because it doesn't exist. So we'll head back to our write function here. And if we go to update status first, and we'll just say hello world. Now update status here shouldn't execute because we haven't created an initial status yet. So you can see here, status does not exist, so we can't update a status. But if we go to create status and we put hello world and we execute that here, you can see our function goes through. We just have to pay the gas to execute it. And you can see our transaction went through. Now if we head to read and we hit get status and we put back our wallet address again and we hit run, you can see our status here is hello world. Now I can head back to write. I can update this status and I can say currently recording third web course video as my new status. And I can update that, execute it, confirm that transaction. And then if I head over to read and get status of that same wallet address, you can see our new status is currently recording a third web course video. So you can see our status got updated for the same wallet address. And again, this is all done through mapping, and we're associating our wallet address to a status structure, which includes the data of the status message and a boolean of if it is true or false if someone already has a status existing. We went through a handful of sample smart contract projects that we created and we deployed them to the Mumbai testnet. And what it went over and covered was some of the basics of Solidity. Now, there is a lot more to creating smart contracts, but hopefully this gives you a good foundational understanding of some of the features and how smart contracts work. Now, we are going to do a little bit more with smart contracts before we jump into building out our application. And in our application, we'll be actually taking these smart contracts that we deployed from the pre-built contracts that we deployed in the last section to some of the contracts that we deployed in this section and actually creating a portfolio-like application to showcase all of the contracts that you created. Now with these applications that we're going to create, we'll be able to interact with them through our application and create a much better user experience than having to go through the Explore tab and call these functions directly through your dashboard. Now to take a look at the application we're going to be building in the next section, you can see here that we will have a portfolio-like application where you can showcase your different projects and smart contracts that you deployed through this course. Now each of these smart contracts have an image and a title that goes along with them that we haven't set up with all of our contracts yet. Now with our ERC 27, 21, and 1155, if we take a look at our contracts, you can see we have our images, and if you remember, we had a settings tab here that allowed us to set the metadata of our contract. And we're going to be using this information within our contract to display that card in our application. Now, if we take a look at one of our contracts that we just deployed that we built ourselves, and we go into settings here, you can see that we don't have access to add any metadata to our contract. And that's because you can see here we're missing the extension to actually add contract metadata. So if we click learn how to enable this extension here, we're going to be brought to the third web documentations under the Solidity documents here. And under extensions and under general, we have a bunch of extensions that are created through third web that you can actually add directly to your applications. So if there's an extension that you want to use that has functionality that you want to use within your contract, you don't have to code out everything from scratch. You can take the extension contract here from third web and simply add it into your contract. This includes drops, this includes permissions, and also things like royalties and primary sales. So just to go over a few primary sales, this allows you to set a wallet address. So instead of funds being directly deposited to your smart contract, like in our tip jar, for example, you can send that funds directly to a wallet address of your choice that you set. Royalty fees and platform fees could include things for secondary sales on marketplaces. We also have things like permissions, so you'll be able to allow permissions of other wallets to do certain things on the contract. But for this one, what we're going to do is add contract metadata. And contract metadata is going to allow us to add that image, title, and description to our contract. So we can see here up top, we have to import the contract metadata Solidity file to our contract. So we're going to copy this here, and we're only going to be using a couple of the contracts that we deployed in our portfolio application. So we're going to be using the tip jar and our profile status. So if we come back to our code editor here and we head over to our tip jar .so here, right under pragma and above our contract, we're going to import the contract metadata .so. We can take a look at the documentations again, and you can see that is where we will import that there. Next, our contract, we have to say is of contract metadata so that we can inherit the functions of the contract metadata file here. So back in our tip jar, we're going to say as contract metadata. And back in the documentation here, you can see that we have to set a deployer. In our case, we named it owner. And we'll also have to call the function of can set contract URI. So we're going to copy this function right over here, come back, and we're going to add this to our Solidity file. And we're going to make sure that this says owner, not deployer, because we used owner within our contract. So with that, we updated our tip jar contract to now allow contract metadata. And we did this by importing a contract extension directly from ThirdWeb. Again, those extensions allow you to use functionalities or pre-built functionalities within your smart contracts. That way you don't have to build them from scratch. So we're going to come back to our command line here, and we're going to run a different command this time. So normally we would run npx thirdweb deploy to deploy our smart contract. But in this case, we're going to do something called publish instead. And what publish is going to allow us to do, oops, if I spell it right, ThirdWeb publish is going to allow us to do is create a pre-built contract that we can showcase just like our pre-built contracts on the Explore page. And we can allow people to deploy this contract themselves by simply clicking one button. So when we run npx thirdweb publish, again, it's going to compile our project. We're going to select the project we want to publish. We're going to select tip jar by using the space here, and then we're going to hit return. Similar to deploy, it uploads the data to our IPFS and it returns us this link here. If we go to the link though, we get brought to this page here. So this page is going to be publishing our contract. Now, this metadata that we see here is not the deployed contract metadata, it's our published contract metadata. So we can just write something like tip jar. We can give a description saying this contract allows users to leave tips and that can be withdrawn by the owner of the contract. Down here, you can actually add a README. So you can add a little bit of a description about what your contract is, how it works. And down here, you have version information, meaning if this is the first time you're deploying one, we can say this is maybe version 1. We can make updates to our contract, and then we can maybe publish an updated version if we added new features, or maybe we had to fix some bugs in it. If you have an audit report, you can also upload that audit report and prove that your smart contract has been professionally audited. And down here, deployment options, we have direct deploy or we have deploy via factory. We're going to select direct deploy because we're allowing people to directly deploy the full contract. Now, again, you can add in all of that information here. Once we hit the next, we can then select the network that we're going to allow this deployment to happen on. So we can select specific networks if we want to. And you can select networks here. Like maybe we only want it for Ethereum and you can publish that contract. Or you can hit all networks and you're allowing that this contract is to be deployable on all EVM compatible blockchains. So hit publish contract here. We'll sign that transaction. And once it has been successfully published, you'll now see we have a page right over here. Now this page here will look similar to if we had one of our ThirdWeb pre-built contract and we head to our Explore page and we select a contract here. Similar to how you see this information here on our Explore page, that is exactly what we just created for our tip jar contract. So you can do this with any type of contract that you create. You can see here on the right, we have the versions. So if we add new versions, you'll be able to select them there. You'll see information by who it was published by. You can view all the contracts by that user's profile. You can edit your own profile if you are the owner of it. So I can add things like an image, a bio, and link my socials here. We can see details on the date that it was published, the licenses that it's using, and the extensions that were used, if any third web extensions were used on it. And again, we can look at the functions, the events that will be called, the actual code to implement this, and our source code right over here. And with that, the publish command actually allows you to create a portfolio of contracts. If you want other people to view your contracts, be able to deploy them yourselves, you'll essentially be able to build your own profile through third web and share your profile with others so that they can see and deploy the contracts that you have created. So if we look at if we hit view all contracts here, you'll see you're brought to your profile page. You can see all the published contracts that person has deployed, and you'll also be able to see deployed contracts on mainnet blockchains here. So if someone has deployed contracts on mainnet, you'll be able to see those contracts here, and you'll be able to see any published contracts that address has. It's a great way to showcase your work. And again, you can share your contracts that you've created with others to deploy. So now that we have this updated version of our tip jar here, we can actually hit deploy now, and we can deploy our own version now directly through this page without having to go through our CLI all the time and deploy it through there. We can now click deploy now. We can select the network or chain that we want to deploy to. We can confirm that transaction, and we can now deploy this contract through our third web dashboard automatically from this contract page. We'll sign to add it to our dashboard. And once deployed, you now see we have a new tip jar contract that is deployed. Now that we have the contract metadata extension added to our tip jar contract, you can see that right over here, extensions, we have contract metadata. We can now head on to settings, and you can now see that this section here is now unlocked, and we can add information like our name, description, and image to our tip jar smart contract. And we can update that with the information that we want to display on our application. So again, we covered how to add extensions to our contracts, and we also learned a little bit more about publish. But we have one more contract that we need to apply this to, which is our profile status. So we'll come back to our code editor here. We're going to go to profile status. What we're going to do before we add in our contract metadata extension is we're actually going to publish this first. So actually, let's come back to our command line here, and we're going to run npx third web publish one more time. We're going to go to our profile status, hit space, and then hit enter to publish it. We'll then take that URL, go to our browser, and then we'll publish our profile status contract. I'm not going to add any description or README here. I'm going to leave everything here. But again, when you publish this, or if you publish any contract, you can add that information in. I'm going to hit next. I'm going to select all networks and publish my contract. We'll sign that transaction there. And there you go. We now have our profile status that is available to one-click deploy. Now, what happens when we want to update this contract, right? So let's head back over to our code editor here, and we want to add that contract metadata to our profile status contract here. So if we come to tip jar, I'm just going to copy that import that we had earlier and bring it on over to profile status. So we're going to change this is contract metadata so that it inherits those functions there. We're also going to come back to tip jar and get that last function there so that we can set the metadata on our contract, and we'll just paste that in down here at the bottom. We can see here that we don't declare an owner. So what we're going to have to do on our profile status is create an address, an owner variable, which will make an address and make it public. And we'll also create a constructor here that sets the owner to the sender or the deployer of the contract. And then down there, that will make sure that the owner can edit the metadata of the contract. So with that, we're going to come back. Let me just clear out my command line here. We're going to run npx third web publish once again. This time we're going to select profile status again, and we're going to publish that same contract. We'll take the URL it gives us. I'm going to paste that in. And again, the information of your contract should come up. And down here under version, you can see that we're now publishing a version 1.0.1 because our latest version was 1.0 and we made some changes to it. We can now say in here, contract now allows metadata through third web's extension. We can now add a new version, write release notes as to what we added in that version, and we can update our published contract. So I'm going to hit next. We'll keep it at all networks and we'll publish the contract here. I just need to sign this transaction here. And we're brought to our profile status contract page again. You can see our 1.0.1 release notes here. Contract now allows metadata through third web's extension. We can go back to our last version if we wanted to. This version you can deploy but won't have the ability to add metadata. So we can always make sure that we select the version that we want, and then we can hit deploy now. We'll deploy this to the Mumbai testnet. We'll confirm that transaction. We'll sign the transaction to add it to our dashboard. And you can see here, we now have our new profile status contract dashboard. And if we head on over to settings, we now have the ability to add and update the metadata of the contract. And again, we're going to be using this metadata to display in our application for our contracts. So you can go through the contracts that we just deployed with the metadata extension, add the images, name, and description of what you want to showcase in your application. And you can do that the same with the pre-built contracts that we deployed in the last section as well. And in the next section of the course, we're going to actually start building out our application here. And again, this is just a quick sneak peek of what we're going to be building. It's going to look a little bit like a portfolio where you can showcase the contracts that you were able to deploy within this course. So we'll have and display the contracts right here on our homepage. You'll be able to select a contract and actually interact with them. So you'll be able to interact with your contract directly through the application and not have to go through your contract dashboard to call functions or read data from your contracts. So we'll be doing our pre-built contracts. We'll be using some of the contracts that we already deployed, like a tip jar here, where you can leave a tip. You'll be able to view the balance or withdraw it from your contract directly from your application. And we'll also be deploying a new type of contract called a staking contract, which allows you to deposit something like your ERC721 token. And in return, you can earn ERC20 tokens for the time that it has been deposited. So in our application section of the course, we'll deploy our very own staking contract using ThirdWeb's pre-built staking contract, and we'll learn how to implement and turn that into an application as well. Now that does it for the smart contract section of our course, and a quick overview of everything that you covered so far. We learned a little bit about the smart contract standards like ERC20, ERC721, and ERC1155. We also learned about ThirdWeb's Explore page and how you can actually deploy pre-built smart contracts directly from ThirdWeb without having to need any coding knowledge or anything. You can deploy your very own cryptocurrency and NFT smart contracts, along with a handful of other pre-built smart contracts that we have to offer. We then learned a little bit about creating our very own smart contracts, learned some Solidity basics, and deployed and published some of our very own smart contracts in this last section. And again, in the next section, we're going to be taking some of the smart contracts we have built and deployed in this section and creating an application that allows you to showcase your portfolio and interact with these smart contracts. And we have covered a lot in this section, so if you do need to go back and rewatch any of the sections to get a better understanding of smart contracts, remember there are timestamps down in the description below. But if you're ready to move on to the application portion of this course and build your very own blockchain portfolio application, head on over to the next section and let's get started. everyone, and welcome to the next section of our course. This section is all about building applications, and specifically Web3 or blockchain applications using Third Web as a tool. Now, in the last sections, we learned about Web3, blockchain, and smart contracts, and we took a deeper dive into smart contracts, created a few of our own, and even deployed our own digital currency and NFT smart contracts. So if you want to head back and review any of that content before getting started in this section, again, all of the information will be down in the description below, and we have timestamps for everything. But again, in this section, it's all about building blockchain applications, and we're going to be building our very own application for ourselves, utilizing the contracts that we built and deployed in the last section. And we'll be building our very own application, which is going to be similar to a portfolio showcasing the smart contracts we built. And in this section of the course, I will be using Next.js and TypeScript to build out the application. But you can also follow along if you're familiar with things like React and JavaScript as well, which leads me to the prereqs for this section of the course. We are going to be building our very own front-end application and showcasing how to use the Third Web SDK. Although the information we share in this section of the course isn't going to be for people who aren't familiar with how to code. You do need a basic understanding and foundation of how to code in these languages in order to continue off in this section. Even if you aren't comfortable with languages like JavaScript, TypeScript, or using things like React or Next.js, you can still follow along in this section, and you'll be able to see how easy it is to implement the Third Web SDK to build blockchain applications. Now, an overview of what we're going to be covering in this section. We're going to prep all of our smart contracts that we deployed and built in the last section and prepare them to be used in our app. We're going to be deploying one more type of contract called a staking contract, and we'll be going over its features and functionalities. We'll then start building out our application. We'll go over how to set up the Third Web SDK with your app, and we'll start to build out our portfolio application one contract at a time. But before we jump into all of that, let's take a quick look at a demo of the application we're going to be building. So over here on my computer, you can see this is our demo application. It is a Third Web demo app, and we have a little title here saying My Contracts, and then we just select a contract to interact with. So from the last section, we deployed our very own ERC20, ERC721, and 1155 contracts. What we're going to be doing with this application is building a front end to actually interact with that contract. So similar to how we're using the Explorer section in our contract dashboard, we'll actually be able to interact with our contract right through our application here. So if we take a look at our ERC20, we'll be able to load things like our supply of our connected wallet. We'll be able to burn tokens, and we'll also be able to earn more tokens through something called staking, which will go on a little bit later in this section. We have our ERC721 contract, which we're going to create this little dashboard here. We'll have the ability to claim an NFT. We'll be able to see some stats on the contract, like the total supply and the total amount claimed. We'll also be able to view how many NFTs from this collection we currently own with the connected wallet. And we'll be able to view our own NFTs right over here as well. And again, we'll be able to stake our NFT to earn some ERC20 tokens. Coming over to our ERC 1155, we'll be able to claim an ERC 1155 token, and we're actually going to configure our contract to make sure that we accept our own custom ERC20 token in order to claim it. We'll be able to see some contract stats here, as well as the NFTs that we own. We're going to come down to the middle here where we're going to see profile status. Here, it's going to load our wallet's current status. And over here, we'll also be able to update that status to any status that we fill in this input right over here. We also have our tip jar, which allows us to leave a tip. We can see the balance of the tip jar here, and we'll be able to withdraw the balance if we are the owner of the deployed contract. And then finally, I'm going to come to the staking one here. We'll get into greater detail when we deploy our staking contract. But what staking allows us to do is deposit an NFT into our contract and in return earn ERC20 tokens. So what we'll be able to do here is stake our ERC721 NFT. We'll be able to view that it is staked. we'll be able to earn a reward in ERC20 tokens, and we'll be able to claim that reward and then use those tokens to claim an ERC1155 token. This is the application that we're going to be building, and it's a way where you can create a portfolio-like application to showcase everything that you've worked on so far in this course. With all of that being covered, let's actually start to prepare all of our smart contracts that we need for building out this application. So the first thing we're going to do is come to our applications here. We're going to edit our ERC20, ERC721, and ERC1155 contracts first. So in the ERC20, what we're going to be doing is going to the settings tab in the left-hand navigation, and we're going to be updating this metadata here for our contract. And this metadata here is what we're going to be using to display within our application. So if we come back to our app here, you can see this is the image that is getting displayed. And when I click into it, we have a title and a description here, which matches the title and description that I have for my contract metadata. Now for the images here, I am using a 16:9 ratio image, but feel free to use any type of image that you want. I would just suggest making them all the same across all your contracts, so all of your images will come out the same size. But what we're gonna do here is update your name and description and add an image here and select update metadata. And you're gonna do that to your ERC20. Same thing to your ERC721, just come over to the settings along with the ERC1155 contracts. Now we did this in the end of the last section, but we updated our tip jar and our profile status smart contracts to accept the contract metadata extension. So what we're going to have to do here is the same as well. In settings, we can add an image and a description and update the name as well here for our contract. And then once you have all of that updated, you should have all 5 of your contracts updated with a contract metadata of an image, title, and description you want to use within your application. The next thing we're going to do is deploy a staking contract. And we'll cover that contract in a little bit more detail right now. So coming back to the Explore page on the ThirdWeb's website, we're going to scroll down a bit and we're going to see a section called staking. And staking here, you can see you can stake your NFTs or tokens to earn ERC20 tokens in return. And essentially what we're going to be doing is we can take a look at our demo application here. We'll head to our staking contract here. Contract is staking our ERC721 tokens. And what staking means is depositing this NFT to our staking contract. And our staking contract is going to then hold on to this NFT. And what we'll be able to do in our contract is set a reward for however long that NFT is deposited in the contract. The owner's wallet will be able to earn a set amount of rewards. We can say for every minute that this NFT is in this contract, you earn 1 token. And we'll be able to set that to any value that we want. So what we'll do here is actually test this in our demo application. So we'll stake this NFT into our staking contract. We'll have to confirm that transaction that appears in order to execute this function. And once our NFT is staked, you can see it is now in the staked section of our application. We have no unstaked NFTs here. And if we wait a bit, we'll start to earn a reward balance. Now, currently I have this set to earn 1 token every 15 seconds. So we'll wait a bit. I'll come back once we have a few tokens that we have rewarded to us, and then we'll be able to claim those tokens. All right, so we waited a bit and you can see here our reward balance. We now have a claimable reward of 3.4 tokens. Now our current balance in this wallet is 400,025 tokens. So when we claim that 3.4, we should get an updated balance amount in here. So with this, we'll be able to claim rewards. We'll confirm that transaction because again, we are executing a function on our smart contract. So we're going to have to pay some gas for it. And you can see we added a little notification here saying our rewards have been claimed. And you can see here our value has updated. We now own 400,030.4 tokens. And again, this is how staking contracts work. We can also unstake our NFT, which is going to withdraw our NFT from the contract and put it back into our own wallet. And you can see here, we now have unstaked that NFT and we now have it back in our wallet right over here. So we're going to deploy this staking contract. And again, in the Explore page of ThirdWeb, we actually have a pre-built contract that does all of this for us. Now, we do have a few staking contracts here. In our case, we're going to do a stake ERC 721, which defines that the staked token, or the token that we have to deposit in order to earn ERC 20 tokens as a reward, has to be an ERC 721. But you can also do this for ERC 1155 or ERC 20s as well. So we're going to select the stake ERC 721. Again, we are brought to the publish page for the contract here, and we're going to select deploy now in the top right. Now we need to add a few things here for this contract. The first thing we need to add is the name of the contract. So we're going to name this ThirdWeb ERC 721 staking. We'll name this stake 721. We'll just paste our description here from our project, and we'll add an image in there as well. Now, compared to some of the other contracts that we've deployed, there are a few more contract parameters that we need to fill out here. You can see here, the first one is the ERC20 reward token address. So this is going to be the token address of the ERC20 token that we want to reward people when they have an NFT staked here. And in this instance, it's going to be our ThirdWeb token here. So we're going to come to our ThirdWeb token contract, copy that, head back to our staking contract here, paste that in. Then the next one is the ERC 721 staking token. So this is the ERC 721 NFT that we have to stake in order to earn this ERC 20 reward. So we'll come over to our ThirdWeb ERC 721, copy that, and then come back here and paste that in. Now the next one down here is time unit for rewards. We can read the description here, and it says that this number is going to be in seconds. And an example is if we want to give out our reward per hour, then we'll have to enter 3600 because that's how many seconds are with 1 hour. Now we're going to do this reward just like how we did the other one, which was 15 seconds. So every 15 seconds, we're going to give out a reward. And we'll specify how much that reward is down here in the reward per unit time. So in here, we're going to say every 15 seconds, how much of a reward is that token going to earn. So if we read down here too, we're also going to have to see, we'll also see that this number has to be in Wei. If you remember, when we deal with numbers that we input into contracts, we're going to have to use the Wei unit. So we can come to the converter here in ethers. We're going to put 1, and we're going to get the value in Wei here, copy it, come back to our contract here and input that reward per unit time. Now the network or chain, we're going to make sure that this is on the same network and chain that we deployed our other contracts to. In my case, I'm using the Mumbai testnet, and I'm going to hit deploy now. We'll get a transaction that pops up, and we'll pay for the gas here to deploy our contract. And then we'll sign that transaction to add it to our dashboard. And once your staking contract has been deployed, you'll be brought to the staking contract dashboard here. Now we do need to set up a few things before this contract is actually ready to be used within our application. Now again, with a staking contract, we are rewarding the users who stake their ERC 721 with an ERC 20 token. Now, the only thing right now is we don't have any ERC 20 tokens to actually reward people from this contract. This contract doesn't own any of those tokens, so we have to be able to deposit some tokens in here so that it can reward those tokens out to the users that stake their ERC 721 token. Now to do this, we're going to have to do a couple of things. So what I'm going to do here is copy the contract address of our staking contract. We're going to come on over to our ThirdWeb token or our ERC20 token, and we're going to head to the Explorer. Now, down in our write functions here, there's a function called approve. And what approve is going to do is we're going to give the address of who is allowed to spend or transfer these tokens. But what we're going to do here is we're going to approve the spending of this token automatically for our staking contract. So in the spender here, the spender is our staking contract. That contract is the one that is going to be transferring these tokens out to people when they want to claim the reward. Now, the amount that we're going to give it the ability to spend, for this example, we're just going to do 100,000. So again, we're going to use the converter. We're going to get that value in away. We'll come back to our contract and paste that in. So what we're doing right now is we're approving our staking contract, the ability to transfer up to 100,000 of our tokens right now. So we're going to execute that function here. And this approval here is normally the transaction that appears, but we're going to take care of this approval for up to 100,000. We're going to hit use default here, which will just make it the value that we are asking it for, which will be 100,000. We'll hit next, and then we'll hit approve. All right, and you can see our transaction went through. So now our staking contract has the approval to transfer up to 100,000 tokens. The only thing is right now it doesn't have the tokens to transfer. We'll have to deposit those 100,000 tokens into our staking contract. So we head on over back to our staking contract and we head to the Explorer tab for this contract. You'll see there is a write function called deposit reward tokens. And what we're going to be able to do here is deposit our ERC20 token, and we'll be able to deposit a certain amount. In our case, we're going to use that same wave value for 100,000, and we're going to execute. So what we're doing now is sending 100,000 tokens from our wallet to the staking contract. And there you can see our transaction went through and we have deposited 100,000 tokens to our staking contract. So we actually take our staking contract address, head back to our ERC20 token, and we head to the read functions here. We can actually read the balance of and paste in our contract here. And you can see our contract or our staking contract has 100,000 of the ERC20 tokens that it's going to use to reward out to people who stake their ERC721 into the staking contract. So now we have all 6 of our contracts deployed and set up. All of them have a image metadata, title, description, and our staking contract is set up to start rewarding people who stake their ERC721 tokens. So now with all of that set, we're going to start building out our application. We're going to take a look at the ThirdWeb SDK and see how easy it is to start building blockchain applications with it. Now that we have all of our smart contracts set to build our application, we're going to start building out our blockchain application using ThirdWeb's EVM SDK. So right now I am on ThirdWeb's docs and we're going to head on over to the EVM SDK. So in the left-hand navigation here, we'll head over to EVM SDK. And the EVM SDK is available in a variety of languages from React, React Native for mobile apps, TypeScript, Python, Go. We even have Unity support for games. But in this course, we're going to be building out web applications and we're going to be using React here. So heading to the ThirdWeb React SDK, you can read a little bit about it here. We're going to head on over to the Getting Started section. And you can see here, Getting Started, if you already have a React project, you can install ThirdWeb's SDK by the install right over here, or you can create a new project, and that's what we're going to be doing by using the npx ThirdWeb create app command. So what I'm going to do here is open up my terminal. And in our terminal here, we're going to run npx ThirdWeb create app. And when we run that, you can see here our CLI is checking for any new updates. You'll see here we do have a new version of the CLI available. So we're going to hit yes to upgrade it. Once it's done upgrading, we'll have to name our project. We'll name this ThirdWeb course app. Then we'll select the blockchain that we're building this application for. So again, we support any EVM compatible blockchain. We also support Solana as well. But again, we'll be using EVM blockchains throughout this course. So we're going to select EVM here. Now here you can select the framework you want to use. Now we're going to be using Next.js, but if you are more familiar and you want to use React, you can use React and still follow along within this course as well. But again, I'm going to be using Next.js. So we'll hit enter here. And then the language we're going to be using for this, we're going to use TypeScript, but feel free to also use JavaScript as well. And you can still follow along if you feel more comfortable using that. So I'm going to select TypeScript here. And once it is done, what we'll do next is change directory into our project here. So I'm going to change into Third Web Course App. And I'm going to use the command here, code period, to open this in my code editor. So once in our code editor here, you can see that we have a bunch of files here, and we need to first set up our application. And there are a few steps that we need to take to set this up. So the first thing we need to do is in our pages folder, we have an underscore app.tsx file. And in our underscore app.tsx file here, this is where the main setup of our blockchain application is going to happen. And you can see here we have a component called the Third Web Provider. Now coming back to our docs and we head on over to the Third Web Provider, you can see it's a wrapper component that provides access to all of Third Web's SDK's hook and UI components. So when we create a new project using a Third Web CLI, this is all set up for us already. Now the Third Web Provider, we do need to provide it with at least two things here. The first one is going to be our client ID, which is our client ID from the API key that we created, as well as the active chain. And this is going to be the chain that our application is going to be interacting with. So we'll do the active chain first, and you can see here that it's referencing our active chain variable, which we have set up here. Right now, by default, it is set to the Ethereum blockchain. Now, what we'll have to do here is change it to the blockchain of the contracts that we deployed. So in my case here, I use the Mumbai testnet. So I'm switching this over to Mumbai. You'll switch this over to whichever blockchain you are currently using. And if you have questions on what should you put into the active chain, you can come to this website here, thirdweb.com/chainlist, and you can search any of the chains that you are looking to add. And when you click on it, you can come down to the code snippet here, and it'll show you what you have to actually put in the string to make sure that you're adding the right chain to your application. But coming back to our code editor here, we have our active chain set. The next thing we need to do is set our client ID. Now, coming back to our file directory here, we have you can see that the client ID is getting grabbed from our environment variable. And if we come to our files here, we have a .env.example file that has our client ID variable right here. I'll close this for a bit. And what we have to do here is paste in our client ID. If we come back to our dashboard and we go to settings, we have our API keys here, and we have the API key that we created earlier. We can copy that client ID right over there, come back to our code editor and paste that in. We'll save that file and close it, as now our client ID is set. Now, what we'll do next is actually run this application. There is some boilerplate code that this comes with. So if I head back to my terminal here, what we'll do is, let me just clear this out really quick. In our terminal here, we're going to run, you can run npm run dev if you have npm installed, or if you're using yarn, you can use yarn dev as well. But I'll run npm run dev in case you don't have yarn installed. What this will do is run this on our local device. So you can see here, we're going to be running this on localhost 3001. So coming back to my browser here, we'll then open up localhost 3001. And you can see right over here, we have a blockchain application all set and ready for us. Now, this is just some boilerplate code that comes when you create an application through Third Web CLI. It gives you links to our documentations or portal, links to our dashboard for your contracts, or you can even clone some templates that we have for things like NFT claims or marketplaces. Right over here, you'll see some information. This is actually a UI component that you get with the React SDK, which is a connect wallet component. And what it'll do is connect any type of wallet to your blockchain application. So let me come here and actually sign out. You can see that this is a connect wallet button here, and we'll actually be adding this connect wallet button into our application and going over it in a little bit more detail in just a bit. But just know that you'll be able to connect a MetaMask or connect a wallet like a Coinbase or any Wallet Connect supported wallet right here, just using this Wallet Connect button. So coming back to our code editor here, again, that was our application that we now have running on top of our computer. So we're going to set up a few more things before we actually start building out this application. And the next thing we're going to do is come to our file directory here, and we're going to create a new folder. And I'm going to name this folder constants here. And this constants folder, we're going to create a file inside of it called addresses.ts. And you can name this JS if you're using JavaScript. We're using TypeScript here, so I'm going to put TS. And within this file here, we're going to create all of the variables for our contract addresses that we're going to be using. So actually, I have it all set here. I'm just going to paste this in, but we're going to export the variable, and we're going to name all of our contract addresses and paste in the string of that contract address so that we can use these variables throughout our application whenever we need to reference the contract address instead of putting in this long contract address right here. We'll also have a better understanding of what address is being used instead of seeing just the contract address and trying to remember which contract that address belongs to. And again, if you ever need to reference your contract addresses, coming back to your contract dashboard, you can just grab them from right here, click and copy, and then come back to your code editor to paste them within the correct areas. And once you have that set, we can close that out. And the final thing we're going to set up is just some styling for this application. Now, I'm not going to go in depth on styling this application with CSS. I actually have all the CSS styles configured for this app, and I'm just going to copy and paste it into our style sheet here. Now, I'll have a link down in the description below to the styles as well. So you can then copy and paste those styles in. That way you can just follow along and we don't need to waste any time styling our application. Now, if you want to style your own application, feel free to do so. I'm just going to have some preset styling here so our application will look nice and pretty as we start to build it out. So in my file directory here, under the styles folder, I'm going to head to this home.module.css here. I have some styles here, so I'm just going to override it all over here and hit save. And I'm going to be using those style class names throughout this application. Again, if you want to copy the same styling that I have, we're just doing this so that our app looks nice and pretty as we build it out. Now in our file directory, I'm going to head over next to the index.tsx file. And this file here, you can see, has some code in it already. And this is the boilerplate code that you saw within the application when we ran it on top of our computer. What I'm going to do here is in the main tag and this first div tag, which has container, I'm going to come into this header div. And in this header div, there's this last component here that has our connect wallet button. I'm going to remove that. And then everything within this div tag right below, I'm going to remove that as well. So what we should have left is our main tag, our div tag. Within our header div tag here, we have our title and our description, and then we have a blank grid div down here. So if we come back to our application here, it should just have our title and our description. So what we're going to do here is our title, and as I'm going to name this, so instead of welcome, I'm just going to say my, and then down here, instead of third web, I'm going to say contracts. And then within this description here, I'm going to delete all of this here, and then just say select a contract to interact with. And we'll just put this all on one line here. And if we take a look at our app now, we have our title with my contracts, which has a gradient. Oh, it actually has a link here. Let's get rid of that link really quick. We don't need it to have a link anywhere. We just need to say my contracts, give it a nice gradient. So yeah, we have my contracts. It has a nice gradient on it. And then our description is select a contract to interact with, where a user will be able to select one of our project contracts here and start to use our contracts. Up here, I'm going to just delete these imports that we no longer need within our app. Save that. And now we have our app set up. So next thing we need to do is start building out our application. We're first going to build out the nav bar. So if we take a look at our demo application, we're going to build out this title that has a link to our homepage here, along with going a little bit in depth on that connect wallet button. Again, the first thing we're going to be building out is this top nav bar here, along with our card components down here, where a user can select the contract that they want to interact with. So coming back to our code editor here, we're going to first create our nav bar. And I'm going to come into my file directory here, and we're going to create a new folder. And we're going to name that folder components. And within that components folder, we're going to create a new file, and we're going to call that the navbar.tsx. And in this navbar.tsx file, we're going to create our navbar component. Now this navbar component here, we're going to create a div, and we're going to give that div a class name. Make sure we import our styles here first. So import, we're going to import that from our home module. So the class name that we're going to give this is going to be styles.navbar. And we have some styling for our navbar there. In our navbar, again, we have two different, let's take a look at our demo. We have our title here, or the name of our application, that links back to our homepage. And then we have our connect wallet button here. So on the left-hand side here, we're going to make a link here. And this link, we can reference it back to our homepage. So we'll just put a slash there. And in our link here, we're going to add a text, and we're going to name our application here. And this one, I'm going to name Watase Portfolio, or say Watase's Portfolio. And we'll add a class name to this one. So we'll add class name styles dot, and then we're going to do the gradient text number 1. So that's going to give our and let's take a look at this within our application so far. So we need to add our navbar to our app. Now we're going to actually add it in our underscore app.tsx file, and we're going to add it right above our components. That way it just shows on all pages of our application. So over here, I'm going to add the navbar component and just save that. And then coming back to our application here, you can see we have our little title of our application right over there. So coming back to our navbar.tsx file, we can also add, let's just add some style here to our title. We'll say cursor, we'll make it a pointer. We'll add font size here. We'll make it to 1.2 rem, and we'll add a font weight and make it bold. So we'll just fix this up a little bit here. Just like that. And then we can take a look back at our app, and there we go. We have this little title of our app, and it just brings us back to our homepage here. So the next thing we need to do is add that connect wallet button. And a connect wallet button will connect a crypto wallet to our application. Now with ThirdWeb and ThirdWeb's SDK, we make this super simple. And all you need to do is add a connect wallet UI component, which is just this component right over here. This is from ThirdWeb. And just like that, that actually adds a fully functioning connect wallet button to your app. You don't need to write any more lines of code. You get this connect wallet button right out of the box using ThirdWeb's SDK. So coming back to our app here, you can see we now have this connect wallet button. We already have our wallet connected. We can disconnect it here. And we now have the option to connect a wallet When we select it, we have our MetaMask, Coinbase, and Wallet Connect. These are the default wallet options, but we can also configure these as well. So we're going to go through some of the configurations here on the Connect Wallet button. Coming back to our docs here, we can scroll down here. We can actually just close these. And we have UI components right here on the left-hand navigation. And we have the Connect Wallet button. And this documentation here will link down in the description below, but you can then start to configure your Connect Wallet button. We have a bunch of different configurations like theme. You can make it dark or light themed. We can change the button title. We can change the modal title. And we can change also the details button, the option to enforce auth. And we can also style this ourselves by adding our own class name. And we can also position the drop-down position as well. So a bunch of customization that we can do to the Connect Wallet button. We'll go over a few of them right now. So in the Connect Wallet button, if we look at our application really quick, by default, this button says Connect Wallet. But sometimes you may want this to say something else, maybe sign in or log in, and we can customize that easily within our component. So in the Connect Wallet component here, we can change the button title, and we can create any string right here that we want it to say. So maybe we want it to say sign in. We'll save that. We'll come back to our app, and you can see now our button says sign in. And when they select it, they can now choose their wallet to sign in with. Next, we'll go over the modal title. So you can actually choose, you can actually customize the title that you see right over here. So maybe we want to change this. Instead of choose your wallet, we'll say select sign in method. So come into our Connect Wallet component again, we can select the modal title, and we can say select sign in method. Save that, come back to our app here. So when we hit sign in, you can see now it says select sign in method. So if we were to select MetaMask and sign in, you can see here that this is the little component that gets shown when someone has a wallet connected. It'll show a symbol of the chain that they are connected to, a balance of the native currency, and a shortened, truncated version of their wallet address, along with a symbol of the type of wallet that they have connected. Now, maybe you don't want to display this in your application. We can actually change this as well. So in the Connect Wallet button documentation here, that's what this details button is going to be. So this details button, we can actually return something, a component, and that component will show instead of that default component that we see here. So if we come back to our code editor, and in our Connect Wallet button, we can say detailed button, and we can now create a component here that we want to return instead. We'll just make it some text here, and then we'll just say and we'll just have it say profile here. So when we save that and we come back to our application here, you can see once our wallet is connected, it'll say profile. You can make it an avatar photo or an icon or whatever component you want to return here. But when you do click on it, you do still have the option to look at your wallet, switch networks, copy the wallet address, sign out if you choose to do so. So again, you have that customization all through the Connect Wallet component, and it's super easy to customize, configure it to match your application. So there you go. We now have our nav bar set up. The next thing we're going to do is create all of our contract cards here that are going to link us to our contracts. So we're going to create components for that and add them to our home page here. So coming back to our code editor, we're going to come to our file directory here, and under components, I'm going to create a new file, and I'm going to name this contract card.tsx. And in this contract card TSX, we are going to now create those contract cards to display on our homepage. Now I'm going to create a type here for our card props, the information that we're going to take for our component so that we can specify what information needs to be shown on top of our card. So we're going to need a link to the page that this card is going to bring the user to. We need the contract address that this card is for. We're going to have the title. which is the title of the card. And then we're going to have a description, which is going to be the description of the card. We're then going to create our component here. And this component here is going to be a link, because it is going to link out to our page to the corresponding page that this contract card is going to allow us to interact with. So the link for this page here is going to be the link href that we provide within our card props here. We also have a class name for this, and we're going to make sure we import our styles here really quick. So import our styles, and we have styles.card here. And within this link here, you can, if we come back to our app and our app demo, we're going to have an image of our contract metadata, along with the title of that we choose, and then the description that we choose. We first need to get the image from our contract metadata. So how do we start getting our contracts, and how do we start interacting with those things within our blockchain application here? So ThirdWeb has a bunch of React hooks that make it super easy. In just a few lines of code, you're able to get your smart contracts and start interacting with them. So coming back to our documentations here, under the hooks here, we have a few main hooks here that we're going to be using. And the first one we're going to be using is this use contract hook here. And you can see the use contract hook is a hook for connecting to a smart contract. All we need to do is provide our smart contract address. And what this will do is get an instance of our smart contract. And the great thing is it takes care of all of the heavy lifting. So normally what can be many lines of code, we can